And let's see if you guys remember how to factor. So just quadratic. I've got x squared minus 6x minus 27. So we're going to multiply a times c and add to b. This first question, my a value is just 1 because I just have 1x squared, right? And c is negative 27. So I got to multiply, find two numbers. I'm going to multiply to get negative 27, add to get the b value, which is negative 6. Now, when you start your factors, you just take that first term and drop the squared and you put it at the beginning of each of the factors because x times x will give me x squared back. Can you guys think of two numbers when you multiply them, you'd get negative 27, same two numbers, you'd add them and it would give you negative 6? Yes, okay, so just one of them's minus 9, one of them's plus 3. Negative 9 times 3 is negative 27. Negative 9 plus 3 is negative 6. That's your answer. That's factored form. Okay, I kind of put one of each type here. So this one, multiply a times c. This would actually just be multiply to get negative 49. And what's my b value for x squared minus 49? There's nothing there, right? So it's 0. Can you think of two numbers when you multiply them, you get negative 49, you add them, you get 0? What do you think? Yes, negative 7 plus 7. So x minus 7, x plus 7. Done. And it doesn't matter, you can put the x plus 7 first, the x minus 7 second. Same thing with that question we just did. It doesn't matter the order you write them in as long as you have them both because we're just multiplying them together. Okay, now I won't lie to you, the one at the bottom, I always feel like these are the trickiest. So if you've got a number in front of your x squared like I do here, just check real quick, see if all three of the terms have anything in common. So like do 9, 19, and 2 have anything I could divide them all by? Unfortunately for this question, no bueno. That's not good, they don't have anything in common. All right, so it doesn't look like I'm doing anything on the first two questions because my a value was 1, but I am multiplying a times c here. For this question, that would be 9 times 2. So the a value is 9, the c value is 2. So I need to multiply to get 18. It's still add to get the b value. You don't have to do anything different with that. That's just going to be whatever's attached to your x. That's negative 19 for this question. So that's what I'm going to try to work through. This, I had you guys do that little Berry method. That is the easiest way I have ever learned to do this, and I know these questions are not easy, but you got to remember, whatever your first term is, if you're going to do this method, you just copy that down, but drop the squared at the beginning of each of the factors. So I'm just going to put a 9x at the beginning of each of these factors. Can you guys think of the two numbers that fit my requirements? Multiply to get positive 18, but add to get negative 19. Yes, okay, so only way for this to happen, they both have to be negative. So negative 1 times negative 18 is positive 18. Negative 1 plus a negative 18 is negative 19. Okay, so for one, we're going to write minus 1. For the other one, we're going to write minus 18. Again, the order for that doesn't matter. Now, this is not the factored form of this because if I multiplied that back out, it's not going to give me what I have above there. What you're looking for, the little trick to this method, if inside the parentheses the two things have anything in common, that's not the real factor. So 9x and 1 were good, but 9x and 18, both of those are divisible by 9, so that's not the real factor. And it's just a little trick to the method. You literally just disappear a 9 out of that factor. So the real factors here, it'd be 9x minus 1, and then this one would just be x minus 2. And again, for any of these, if you want to just spot check real quick, I usually just check the first and last terms because it should give you the first and last terms in the original. So like if I do 9x times x, that will give me the 9x squared. And if I check the last two terms, negative 1 times negative 2, that should give you the number on the end, which is 2, which both of those work out for this question. You could fully FOIL it out if you really want to check it, but you should be okay if you just check those two. Is anybody having a question? Okay. Now, these questions down here almost look identical. Almost. So, part A down here is going to kind of match up with part A in the first exam, or the review up there at the top. The only difference is I changed this up. Instead of being x squared minus 6x minus 27, this is x to the fourth minus 6x squared minus 27. So really similar. These are all quartic expressions, so x to the fourth. Does anybody know, it's going to look really similar. There's literally like one thing you would change. Does anybody know what the factored form would look like if I had x to the fourth minus 6x squared minus 27? It's super similar to this question right here. This one at the top. Super similar. There's one thing that's different. So it's almost identical to this. I'm just changing the powers of x. Anybody know how this would be different? Okay, let me ask you this question. If I have to put the same two things at the beginning of each of these, and I need the result to be x to the fourth, what would those both have to be? Because I would multiply them together. X squared. It's literally the only difference. Instead of an x, you just use an x squared. That's literally the only difference. The two factors are the same. One of them's still a -9 and one of them's still a +3, but that's literally the only difference. It just has to be x, and it has to be in that format. It has to be x to the fourth, and then no x cubed there, an x squared, there's no x, and a plain number, kind of the same format as a quadratic. The only difference is you just use x squared instead of x, and that's done. So like this one, this is x to the fourth minus 49. You would just do x squared minus 7 and x squared plus 7. It's identical to factoring what we just did above. It's just where I put an x up above for the quadratic. For the quartic, you're just going to put an x squared. And so for this last one, again, it's the same thing I did above. That Berry method and everything would work. It would just be 9x squared minus 1 and then x squared minus 2. You just use an x squared instead of an x. When you do the x squared times x squared, that gives you the x to the fourth. And then that middle term will both be just x squareds. And then the plain number on the end, -1 times -2 for that question. Is anybody having a question? If you can factor quadratic, you can do this. Okay. Now, this is going to kind of reiterate some stuff we've already been talking about, but I'm just going to write it for you here. So we're going to solve some of these. Those are all expressions on the front. We're going to use factoring to solve these on the back that are actually equations. But just at the top, just a little summary. The number of solutions or answers or roots or zeros or whatever you want to call them is going to be equal to the degree of your polynomial. And if you're like, what are you talking about by that? The degree is just the highest power of x. So if you look at your polynomial, whatever term has the biggest exponent, that's going to be how many solutions you have, the highest power of x. Okay, now, if we were to graph any of these on Desmos, which you could do if you want to, it says if the solutions are real, so that means they don't have an I in them. We had a bunch with I's yesterday. If they're real, you can see them on a graph, and these would be x-intercepts. So where the graph would cross or touch the x-axis, so your zeros if you were looking at your graph, called the x-intercepts. Now, what you can't see on the graph is if the solutions are imaginary. So those will have an I. We were working on sum and difference of cubes yesterday. Those have two imaginary answers in each, and you can't see those on the graph. So since we can't see them on the graph, we're going to have to use some type of algebra to solve for them. Okay, now this says, we're going to factor today like we did yesterday. If all the factors of the polynomial are not linear, so a linear factor would be, I don't know, like x plus 4 or like 3x minus 2. Those would be examples of linear factors. You just have an x. You don't have anything higher than that. If they're not linear, you have to at least get them down to be quadratic factors. And then quadratic factors like we had yesterday, I don't know, I'm just making something up, like, I don't know, x squared plus 4x plus 16 or something like that. That's quadratic. It just means it has an x squared. If we can at least get it down to a quadratic, we can always use the quadratic formula, or in some cases, which you're going to see today, you can actually just use square roots, which is what we're going to do for these questions down here. All right, is anybody having a question at the moment? Okay, now these first three are just the three that we were working with on the front. I just turned them into an equation. All right, so I'm just going to rewrite. We already factored these. X to the fourth, this becomes x squared minus 9 and x squared plus 3. That was the factored form. Okay, this is nice for us. If you're in factored form, right, I've got two things multiplied together to give me 0. So, if you remember doing this from just a quadratic, either x squared minus 9 needs to be 0, or x squared plus 3 needs to be 0. So, I'm going to show you this real quick. If you look at the original problem, I've got x to the fourth minus 6x squared minus 27 equals 0. Whatever the highest power of x is, which is 4 here, that's how many answers I should have. So I'm going to have 4 answers. If I solve these two little equations, I'm going to get 2 answers out of each one of those. So, like, all I have to do here, we're just going to use square roots. I don't have to do anything fancy. You could use the quadratic formula if you're bored, but I would just, you can get x squared by itself. So I would just here, I would add 9. So I'd get x squared minus 9. How do I get rid of the squared? Like, I got x squared equals 9. How do I get rid of the squared? So it's just x. Square root. Okay, now, this, if you remember, we introduced the square root in the problem, right? So I automatically put the plus and minus. When I put that plus and minus, I automatically get 2 answers. So I'm trying to get 4 answers here. Right now I have 2 of them, 3 and negative 3. Just plus and minus, just a little shorthand way to do it. The other one's a little bit trickier. So for this one, I would have to subtract 3 from both sides. And then this is going to land me with x squared equals negative 3. Now, we have to deal with this with an I, because I'm going to end up taking a square root just like I did on that other equation. But since we have a negative under a square root, 3 doesn't break down under a square root. So what you would write, you're just going to pull plus and minus, because we introduced the square root. So this is going to be my other 2 answers. Just put an I out in front of that. That takes care of the negative. So I have a 3 still under the square root there, because 3 is not a perfect square or anything that doesn't break down. But we're just going to pull an I out in front so we don't have that negative under the square root. So my other 2 answers, these are my other 2 answers here. Plus and minus gives me 2 answers. They're just imaginary, so we wouldn't be able to see those on a graph. Does anybody have a question? Okay, let me try that. We already factored this. So this is x squared minus 7, x squared plus 7. So again, I got 2 little quadratics multiplied together set equal to 0. So if this guy was 0, so x squared minus 7, or if this guy was 0, x squared plus 7, set those equal to 0. Again, my highest power of x on this original equation is x to the 4th before we wrote it in factored form. So again, I should have 4 answers to this question. And I'm going to get 2 out of each. So this guy right here, we're going to add 7. So then I'm going to have x squared equals positive 7, square root, and then it's positive number. So I introduced a square root. I get 2 answers out of this because of the plus and minus symbol. And I can't break down 7 under a square root, so just be plus or minus the square root of 7. 2 answers right there. Now, the other one's going to look super similar, but this one I would subtract 7 from both sides because our other factor was x squared plus 7. So then we get x squared equals negative 7. So when I take my square root, we got a negative under the square root. Only difference is when I put my plus and minus, we're just going to write an I in front of this to take care of the negative, and then 7 would stay under the square root. You can't break that down. Does anybody have a question? Okay, this is the last one that we did that we've already factored. So let's just try this one here real quick. So this one, what was this? This was 9x squared minus 1 and then x squared minus 2. That was the factored form we had for this. We've been doing this question. This is the third time we've done this question. Okay. Now, this one's an extra step because I got a number in front of the x squared. But if 9x squared minus 1, if that was 0, we would have 2 answers from that. Or if x squared minus 2 was 0, we'll have 2 answers from that. So 2 things multiplied together to give me 0. If one of them's 0, it's going to wipe out the whole thing. If the other one's 0, it's going to wipe out the whole thing. Now, this one is an extra step. So I'm going to add 1, and I get 9x squared equals 1. Do not take the square root until you have the x squared totally alone. So before I take the square root, I need to divide both sides by 9. So if I'm doing that, I get x squared is equal to 1/9. So we're going to take square root, and then automatically when I introduce that square root, I get 2 answers out of that because I get the plus and minus symbol. Anybody know square root of 1/9? It's a nice number. Oh, well, it's a nice fraction. We'll say it that way. Like if I take a square root of 1/9, what are you going to say? 1/3. Yeah, 1/3. So square root of 1 is 1 on the top, square root of 9 on the bottom is 3, so it'd be plus or minus 1/3. The other one, just super quick, I'm going to add 2. So we would have x squared equals 2, square root, and so x equals, I automatically get 2 answers out of this because we get the plus and minus, and it would just be square root of 2. There's no I involved in that because I never ended up with a negative there. Okay, now 2 totally new questions. We haven't done anything with this today. See if you can do these, guys. All right, now it's x to the 4th, so it's quartic, plus 4x squared minus 32. We're going to factor this just like a quadratic. The only difference is we're just going to use an x squared at the beginning of each of the terms instead of a plain x. That's the only difference between that and a quadratic. All right, so I'm going to multiply to get that negative 32 and add to get 4. Can you guys think of 2 numbers? If you'd multiply them, you get negative 32, but if you add them, you get positive 4. So I got to think of factors of 32. So I got 1 and 32, 2 and 16, 4 and 8, and I think that's it. How can I get a combination when multiply to get me 8 and negative 4? Good. So one of these is a plus 8, one of these is a negative 4. Okay, now 2 things multiplied together give me 0. So if x squared plus 8 was 0, we'd be golden. Or if x squared minus 4 was equal to 0, we would be golden. Okay, now the very first one, sorry, this is a little bit annoying. So I'm going to subtract 8 from both sides. I get x squared equals negative 8. Now, on the other questions we've done so far, what I had under the square root, which I am going to have a square root here, we were not able to break down because they were prime numbers and they were not divisible by any perfect squares. But on this one, I can break down negative 8 under a square root a little bit. So this would be, we'd still have the plus or minus. Okay, easiest way I can tell you to do this, the biggest perfect square that would go into 8 would be 4. And so I'm going to rewrite that real quick as negative 4 times 2, 4 being the perfect square, and I just attach a negative to that. Now, when I take a square root, I attach the negative to the perfect square because that's a perfect square in imaginary land. Square root of 4 is 2. Square root of negative 4, you're just going to write 2i to take care of the negative. And so 2 answers right there. You have plus or minus 2i radical 2. The other one, super easy, I'm going to add 4. So I'm dealing with a positive number. X squared equals 4. Square root. And automatically when I introduce that square root, I get 2 answers. This is plus or minus 2. So positive or negative 2. And then I've got 4 answers. 2 here, 2 here. X to the 4th was our highest power for that question. And I have 1 left, and then I'm going to be quiet. All right, so remember, if it starts with x to the 4th, this is going to be like a difference of squares, but I'm just going to do x squared instead of a plain x when we're dealing with x to the 4th. So what two numbers multiply to give you negative 81 but add up to 0? We think two numbers, we multiply them, we get negative 81, but if we add them, they would cancel each other out. Yes, 9 and negative 9. Okay, one's a plus 9, one's a minus 9. All right, so really quick, both of these will have decent answers. So we're going to set these equal to 0. If I have x squared plus 9 equals 0, sorry guys, I'm really close to the bottom of the page here. I'm going to subtract 9. I'm just not going to write it because I wrote too big. So this one would be x squared minus 9, or equals negative 9. I apologize. Now, square root both of those. 9's a perfect square, negative 9's a perfect square in imaginary land. We're just going to put an I with it. So when I introduce that square root, automatically I get the plus and minus. So 3i. And then the other one, I'm going to come over here. I have x squared minus 9 equals 0. For that one, to solve it, I'd actually add 9 to both sides. So we have a positive number, so we won't have any i's here. I do introduce a square root to get rid of that on the x squared, and I automatically get 2 answers out of that. So that would be plus or minus just positive 3. So the 4 answers, you got plus or minus 3i, and then you have plus or minus 3.